Welcome everyone. Let's look at a concept, a simple concept called electronic configuration. We saw that the atomic number is the number of protons in the nucleus of an atom. And we highlighted that the atomic number identifies an element. That is to say that each element has its own atomic number. Each element has its own number of protons. And it's what distinguishes it from others. Because the number of electrons is actually equal to the number of protons. And therefore, the number of electrons, especially in the outermost shell, also plays an important role in what elements or what compounds that element can combine with. So that means that it has the atomic number in relation to also the number of electrons. They play an important role in determining the chemical characteristics of a particular compound or a particular element. Okay. In this case, we are looking at, in this presentation, we are looking at how these electrons are arranged across the different shells of an atom. That's what we call electronic configuration. How are they arranged? Okay. What rules do these electrons follow? If you're going to write the electronic configuration of an atom or an element, what rules do we follow? Okay, so that's something that we're going to look at. So electronic configuration, it shows the arrangement of electrons in the different energy levels or in the different shells of an atom. Okay, so let's look at the rules. Rule number one is that the innermost shell, remember the shells are these circles, they are these circles that we are representing here. We call them orbits, we call them energy levels, we call them shells. Okay, so the names can really vary. But we are saying that the innermost shell should have a maximum of 2 electrons. That's a rule here, rule number one, that the innermost shell should have a maximum of 2 electrons. If you have more other electrons, then they can come in the subsequent shells. Okay? That's rule number one. You cannot fill the second shell without filling the first shell. That's rule number two. Okay? Fill the inner shell. After filling the inner shell, you move the second one. After filling it, you can move the third one. But you cannot start with the third cell, move the second, and move the first. No, that's not how we do it. That's clear, right? So the energy level is a possible location around the cell where the electron can be found. The electrons, we say that they keep revolving around the shell, around the shell. So each energy level is represented by n is equal to 1 or 2 or 3. Okay. So just this is what you see. So this is the first energy level, the second energy level, and the third energy level. So let's look at sodium. Sodium has, I don't know why this is like this. Sodium has the number of protons is 11, okay, and then also the number of electrons therefore is 11, and then the electronic configuration is this. This is the electronic configuration of sodium. So how do we write the how do we come up with that electronic configuration? So we are saying that the number of electrons is 11. So you first fill the first shell, right? And the first shell takes maximum of 2 electrons. So we are starting with, that's the nucleus of sodium. And then the first shell is having 2 electrons. So we come to the next shell. The second shell must have a maximum of 8. That's another rule. Okay, the second and the third cell cannot have more than 8 electrons. Okay, so 2 already in, meaning that we are left with how many? We are left with 9. So we also put the maximum, which is 8 here. So those are 8 electrons, right? How many are remaining? 1 electron is remaining. So you put another shell and have 1 more electron there. Okay, so this is basically what you have here. The innermost is 2. That's the 1 shell. The next one is having 8. The next cell is having 1. So this is the electronic configuration of sodium. Have you noticed the rules? You first fill the innermost shell and it takes the maximum of 2. The subsequent shells, 2 and 3, and maybe others, the maximum they can take is 8. Okay? So we have the first 20 elements with their electronic configuration. What you just need to know is the number of electrons. After knowing the number of electrons, then you can be able to write the electronic configuration. Okay? So the number of electrons is 5. You first fill the innermost. The next one should have 3. You can put here and then here. So that is that. This is what you have here. Electronic configuration of 6 with the 6 electrons. You first fill the innermost with the 2, followed by remaining, of course, 4. That's what you have there. You can have that star or you can represent them with the dots. You can represent electrons with the dots. And then this is the shell, it's the nucleus inside. Is that quite okay? So that's the same things. Okay, so these are some of the things that can be asked. You can be asked to write the electronic configuration of aluminium. Aluminium has how many electrons? 13. Okay, had 13 electrons. So this is the nucleus, the innermost shell. So you put your electrons 2 maximum here, another 8, another 8. So we have 10 already. So the outermost should take 3. 1 there, 1 here, 1 there. And that's what you have there. Lastly, let's look at one concept called isotopy. You can use isotopy. That's the concept, or what you call isotopes. So what does this really mean? What this means is that you can have different atoms of the same element with the same number of protons but different number of neutrons, and therefore you have different atomic masses. The examples are chlorine, chlorine here. This is the atomic mass. Different atoms of chlorine, they have the same atomic number. That means they have the same number of protons, but the number of neutrons is different for each of those atoms. Okay, so therefore that means that the atomic mass is different. Remember, atomic mass is equal to the number of protons plus the number of neutrons. This is the number, okay? That's what we call, but we are saying this is the same, but this one is always different. For the atoms of the same element, okay, and therefore you have this one as different. That is what you call isotopy. So the definition for isotopy is that it is the existence of atoms of the same element with a different number of neutrons, but the same number of protons, and therefore they have different atomic masses. Okay, and examples include chlorine and carbon here, but of course there are others, but in this we are talking about carbon and chlorine. We have a chlorine atom that can have 17 protons and 17 electrons, but you can also have another atom that can have 18 or 20 neutrons, different number of neutrons. The same thing happens with carbon. Okay, you have carbon with 6 protons, but you can have carbon that has 6, 7, or 8 neutrons. Okay, so that marks the end of this presentation, where we have looked at electronic configuration. Electronic configuration refers to the arrangement of electrons in the different energy levels of an atom. It follows some rules. Rule number 1 is that you have to fill the innermost shell first, and the innermost shell takes a maximum of 2 electrons. The subsequent one, 2 and also 3, they can take a maximum of 8. Okay, so you go on until you write the electronic configuration. And then finally we looked at isotopy, which is the existence of atoms of the same element but having the same number of protons but different number of neutrons, therefore different atomic masses. Carbon and chlorine are the examples that we have listed here. Thank you.